All right, let's get straight to it. We are officially in a new era of AI, the age of agentic AI. I want you to treat this as a critical security briefing because the protocols we're about to cover, they are absolutely essential for protecting the systems you're building. You know, the systems you're designing don't just suggest things anymore. They take action. They can call APIs, they can move data, they can even spin up sub-agents to help them out. And that, right there, fundamentally changes the entire game for security. And let me be perfectly clear. The principles we're about to cover are completely non-negotiable for system integrity. In this field, the room for error is practically zero. So here's our game plan. We'll start with what this agentic shift really means. Then we'll break down the different types of agents you'll be working with. After that, we'll map out the threats, establish our defensive doctrine, look at the specific tools you need to use, and wrap up with the single biggest responsibility that falls on your shoulders as an engineer. Okay, let's really dive into this. The big fundamental change here is that AI has gone from being a consultant to being a worker. It's not just about predicting an outcome anymore, it's about actually taking the steps to make that outcome happen. Look, you can't secure a system if you don't understand what's inside it, what its parts can do, and just as importantly, what they can't do. So let's profile these agents. First up, the Simple Reflex agent. This is the most basic one you'll see. Think of it like a thermostat. It reacts to one single thing, an immediate input, and it has zero memory of the past. If the temperature drops below X, turn on the heat. That's it. Super simple. And this analogy just perfectly illustrates its biggest weakness. A traffic light on a timer is going to turn red whether there are 100 cars waiting or 0 cars waiting. Why? Because it can't adapt. It has no memory, no concept of the world's current state. So here's the really crucial point. Because this agent has no memory, it's just doomed to repeat its failures over and over again. It literally cannot learn from its mistakes. Now, we're going to come back to how we defend against this, but for now, just burn this limitation into your brain. No memory equals no learning. Now that brings us to the next level of agent, which adds that one critical component, memory. This agent keeps an internal model of the world, a state. Think about a robotic vacuum cleaner mapping out your living room. It remembers where it's already been, so it's not just reacting to the dust bunny it sees right now, it knows which parts of the room it still needs to get to. Okay, let's compare two of the more advanced agents. First, you've got the goal-based agent. Picture a self-driving car whose only goal is to get to a destination. Any valid route will work. But then you have the utility-based agent. It's way more sophisticated. It tries to figure out the desirability of different outcomes. It asks, what's the best way to get there? It might pick a route that's not just successful, but also the fastest, the safest, and the most fuel efficient. The problem? Every one of those factors, speed, safety, efficiency, is a variable an attacker can try to manipulate. That creates a much, much larger attack surface. This brings us to the most powerful and, frankly, the most dangerous agent type. All the previous agents, they operate on known paths or goals. A model-based agent is like driving a car with a map. But a learning agent? It's like being dropped into a complex maze without a map and having to figure it out. It learns from experience, adapting and exploring through trial and error. And this shift from predictable execution to unpredictable, emergent behavior, well, that's where you find both the highest risk and the highest reward. So how does this learning thing actually work? Well, it's basically a 4-part loop. First, the performance element takes an action. Then, the critic looks at what happened and gives it a score. Based on that score, the learning element updates the agent's overall strategy. And finally, and this is so important, the problem generator actually pushes the agent to try new, sometimes risky things, so it doesn't just get stuck doing what it already knows. It's this constant cycle. Act, get feedback, adjust, and explore. All right, so now that you know the different agent types, let's start pinpointing their specific weaknesses. You have to remember, every new capability introduces a new vulnerability. Every single agent, I don't care if it's the simplest or the most complex, follows this fundamental loop. It senses the world around it, it reasons based on its internal logic, and then it acts. Each of these 3 stages is a potential door for an attacker to walk right through. It is absolutely critical that you understand the difference between these 2 threats. Prompt injection, that's a direct, real-time attack on the agent's immediate logic during that sensing phase. But data poisoning? Oh, that is so much more insidious. That's someone corrupting the agent's core knowledge during the reasoning phase, tampering with the very foundation of its mind. So, to defend against these kinds of threats, we are not going to just build higher walls. No. We're going to operate under one core assumption. The breach has already happened. This is the zero trust doctrine. These aren't suggestions, okay? These are the foundational principles for building any secure agentic system. We assume the bad guy is already inside. We only grant permissions at the exact moment they're needed. We embed security controls everywhere in the system. And we constantly verify the identity and intent of every single actor, whether that's a simple agent making one API call or a complex learning agent trying to spin up a new resource. Never trust, always verify. Now let's translate that doctrine into concrete actions and tools that you are required to use. This is your standard operating procedure from now on. Think about it. The very first place any attacker is going to look is for the keys to the kingdom. How your agent authenticates itself to call a tool or access a database, that is your primary line of defense. Let me be absolutely 100% clear on this. Embedding credentials, passwords, API keys, anything directly into your code is a fireable offense. It is the digital equivalent of taping the bank vault keys to the front door. Do not do it, ever. All credentials, every single one, must be stored and managed in a dynamic credential vault. An agent's non-human identity has to check out a credential for one specific task, use it, and then that credential must be immediately revoked or destroyed. That is just-in-time access in practice. For a simple agent, that might be a credential that's valid for 5 seconds. For a complex learning agent, the principle is exactly the same, the least privilege for the shortest time possible. Your playbook from here on out is simple. First, you'll maintain a registry of trusted tools. If a tool isn't on that list, the agent can't call it, period. Second, all input and output will pass through an AI gateway for inspection. And third, every single action will be recorded in immutable logs. Remember that simple agent that kept repeating its mistake? This is how you would have caught it. This tamper-proof audit trail is what gives you that preventive insight. But ultimately, when all the other guardrails fail, when a learning agent starts showing emergent behavior that is dangerous or just completely unpredictable, the final control rests with you. And this is not some hypothetical, philosophical question. Before you deploy any autonomous system, you must define the precise conditions for its termination. You have to know, without a shadow of a doubt, when it's time to make the call. That concludes this briefing.